Section 3-20 is called heat transfer by convection. The basic idea here is that warm air or warm fluids in general tend to rise and the cooler falls. And there's this natural process of convection where that occurs in nature. It occurs also in electrical machines. It occurs in a lot of different things that we can think about. The idea earlier when we had a metal bar, you know, and we were holding a candle to the bottom of it, you know, and it caused the bar to heat up through conduction. Well, in addition, as that bar heats up, the warmer air that surrounds the bar tends to rise as well. Let's look at another view of this and see if we can get a better understanding of what's going on with it. This is figure 321 in your text, and you know, a good thing to think about this as being a transformer case or tank, and the transformer is actually submerged in a cooling oil internal to that. You can think of that, you know, here in this figure 321. And again, the general idea here is that warm air or warm fluids rise, cool falls, and while this happens, it creates these what are called convection currents. And there's two types of convection. There's something called natural convection, which just occurs, say in particular with, you know, this tank, these convection currents here that are showing, you know, with the warm, you know, tending to rise here. That's just a natural occurrence that's going on here. And then there's also something that we use in electrical machines, motors, forced convection, where and most electric motors use some type of fan to force air across something, you know, and that's called forced convection. So, you know, this is the general idea. The section 320, you know, just talks about this as a way to transfer heat. And what you might see, say for instance, in this tank that we're looking at, you know, this heat that's generated here, say this is that transformer that's immersed in this oil. What happens, you know, as this warmer oil rises, there is a surface area exposed to the outside, and that's how the cooling actually occurs. Now, in the next video in 321, we can quantify this, and we have an equation that's associated with it.